Hello students, today we are going to discuss very short questions of intermediate public examination, physics questions, intermediate first year. So the weightage of the chapters, blueprint according to that, we are following most important which are coming in the public examination. Students, I am Srinivasan. I am from Spark Academy going to teach you first year very short questions today, completely all the chapters. Very information. ఇంకా డార్క్ ఉండాలా ఫస్ట్ ఇయర్ VSAQs. Now first we are discussing some questions in physical world. First question, general question. What is physics actually? This is subject physics. What is physics? What is physics, students? Answer. Physics is a branch of science. Physics is a branch of science dealing with thickness ఎక్కువ ఉంది. Physics okay student, why repeat once again? Physics is a branch of science dealing with fundamental laws of nature, and their manifestation and demonstration, experimental ways. Physics is a branch of science dealing with fundamental laws of nature and their manifestation and demonstration. Example is gravitation, laws of nature. We are learning gravitation. Planets are revolving around the sun in elliptical orbit. Why they are revolving around the sun? Due to force of attraction between the sun and the planet, it is able to revolve in elliptical orbit. Now this is first question. Second question, what are fundamental forces in nature? What are fundamental forces in nature? What are fundamental forces in nature? What are they? Different types of forces in nature we are discussing. First one is called gravitational force. Gravitational force. Second one is called weak nuclear force. ఒక క్వశ్చన్ ఒకటి ఓకే మళ్ళీ ఆయన సెకండ్ క్వశ్చన్ ఓకే what are the basic forces in nature? What are the basic forces in nature? Answer. What are the basic forces in nature? First one is called gravitational force, attractive force, gravitational force. Next order, weak nuclear force. In nuclear, between nucleons, force is there, weak nuclear force. Next one is called electromagnetic force. Next one is called electromagnetic force or electric force and magnetic force. Last one is called strong nuclear force. Strong nuclear force. So if you think these four forces, what is the comparison? Weakest force is gravitational force, students. Next weakest force is weak nuclear force. Next, like that, strongest force is strong nuclear force. So number one, electromagnetic force. Next, weak, and then comparison. You give some names like that. You give names. First one, F1. Right? F1, F2, F3, F4. For example, I'm naming. What is the nature here? F4 is greater than F3, is greater than F2, is greater than F1. This is the comparison between the basic forces in nature. Question number 3. What is C.V. Raman discovery? What is C.V. Raman discovery? What is the discovery of C.V. Raman? What is the discovery of C.V. Raman? What is the discovery of C.V. Raman? C.V. Raman, a scientist, Indian scientist settled in abroad. C.V. Raman, very important scientist. What is the solution here? C.V. Raman discovery is called Raman effect. C.V. Raman discovery is called Raman effect. First 2 marks are there now. First you have to write this one. Raman effect. What is Raman effect tells it is Raman effect. What is the Raman effect telling is dealing with scattering of light. Raman effect. What is Raman effect? Deals with scattering of light. Deals with scattering of light by molecules of the matter, liquid or solid. It deals with the scattering of light by molecules of the matter, molecules of the medium, molecules of the matter or medium, molecule of matter or medium. This is enough. If you write, this is enough. What you have to write, this is a very, very important question. Discovery of C.V. Raman. It is called Raman effect. It deals with the scattering of light molecules by matter or medium. This is the third question, important. Next, fourth question is, what is Chandrasekhar limit? What is Chandrasekhar limit? Chandrasekhar limit is study of stars here. Chandrasekhar limit is the study of the stars. What is Subramanian Chandrasekhar? S. Chandrasekhar. He is also Indian scientist settled in abroad. Chandrasekhar limits. S. Chandrasekhar limit. What is S. Chandrasekhar limit is contribution. What is the contribution of S. Chandrasekhar limit to physics? Chandrasekhar limit tells about S. Chandrasekhar. Answer. S. Chandrasekhar limit tells about structure and evolution of stars. Structure and evolution of stars, galaxy. S. Chandrasekhar limit, after that limit it comes to black hole amount. S. Chandrasekhar limit tells about structure and evaluation of stars, my dear students. These 4 are very, very important questions. Out of 5, these 4 are coming always. What is physics? What is the discovery of C.V. Raman? What are the fundamental forces in nature and comparison? And what is the contribution of Chandrasekhar limit? What is S. Chandrasekhar limit to physics? This is the last question. Next chapter. We are going to next chapter. Next chapter, units and dimensions. Next chapter, second chapter, units and dimensions. Units, dimensions, errors. So in this, the question number 1, what is the question number 1 in this? Again, question number 1 in this, what is the question number 1? Distinguish between accuracy and precision. Distinguish accuracy and precision. Accuracy and precision. Decrease and precision. This comes in errors. What is meant by accuracy? I'm writing first accuracy. Accuracy. If the measured value is close to true value, the measured value of a quantity is close to true value, it is said to be accurate. It's said to be accurate. So true value minus measured value. True value very close to measured value. G 9.8 is there. You are getting 9.792. So what is the difference between them? So 9.72 is will understood to be close to 9.8, like that. That is called accuracy. But what is meant by precision? Precision depends on the least count of the instrument. Precise need not be accurate. Precision depends on the least count of the instrument. So it may be accurate, may not be accurate, but least count. For example, the meaning of this one is length. Example, you are giving length, you are getting 5.6 centimeters with scale. Length with scale. But some other instrument, vernier calipers length you may get 5.64 centimeters also by vernier calipers. So you are getting second decimal place. That is called precision. But you are not getting for. But maybe your true value may be 5.58, maybe close to scale reading only. Even though you are getting 5.64, sometimes it may be accurate, may not be accurate. So you are getting second decimal place or third decimal place. That depends on the instrument. Vernier caliper has screw gauge. So precision depends on the least count of the instrument. So you get the value. I have one example. Accuracy. You can write as a tabular form, or you can write definition like this. This is 1 mark. This is 1 mark. Distinguish between accuracy and precision. Next question. How can systematic errors be minimized? How can systematic errors be minimized? Minimize means reduced. Be minimized. How systematic errors can be minimized? Systematic errors means parallax error, careless. For example, you are doing the instrument by side, you get parallax error. How to avoid all those things? How types of errors? Systematic errors coming in the reading, or your carelessness means personal bias. You have to remove all these things. So you take sometimes instrument is fault. You get. So you have to take better instrument for that. So how to avoid all those things? First one, by using better instruments and better experimental techniques. Experimental techniques. You can avoid systematic errors. And then avoiding personal bias. Avoiding personal bias Personal bias. Personal bias means what? You have to see without parallax error and should not do careless handling of the instrument. So you should not handle very carelessly. Personal errors and all these things you have to avoid. Personal bias means that one. Better instrument. By using better instruments, better experimental techniques, definitely systematic errors can be minimized. These are two important things. How can systematic errors can be minimized? This is very, very important question. Next question. Distinguish between fundamental units and derived units. Distinguish between fundamental units and derived units. Next question. Distinguish fundamental units and derived units. Fundamental units and derived units. And derived units. Okay, friends. Distinguish between fundamental units and derived units. Answer. What are fundamental units? Fundamental quantities. There are many things. I'll write some of them. Fundamental quantities and units. Quantities and units. I'm writing. What are they? Mainly mass, length, time, temperature, etc. I'm writing three or four if you write enough. What are the units? Mass unit, fundamental unit kg, plural also kg only. Length meter, time seconds, temperature Kelvin. These are fundamental units. They are independent units. What are fundamental units? They are independent units. They are independent units. They cannot be derived. They are independent quantities and they are independent units. What is derived quantities? What is? Again, I will tell you fundamental quantities. One previous question. Previous question. Next question. Next question. Distinguish fundamental and derived units. Distinguish fundamental and derived units. And derived units. Answer. You know fundamental quantities are fundamental quantities. Students, fundamental quantities and units. Fundamental units I am telling. What are they? Mass, some of them I am writing. Mass, length, time, temperature, etc. Current also you can write if you want. Temperature, etc. Their units are kg, length meter, time seconds, temperature Kelvin. What is derived units? I'm writing what is derived units. Derived quantities and units. Derived quantities can be derived from with the help of fundamental derived quantities and units. I'm writing. What are they? Some of them I'm giving. Area, second density, third velocity, force. Like this I am giving you. What is area? Area depends on length and to length. Area if you take, area depends on length. So area units are, what is area units? Meter square. area units are, this is derived unit, length into length. Density, mass by volume, density, mass by volume, hence its units are kg per meter, SI units, I am writing SI units. Density SI units are kg per meter cube, because density is mass by volume. This is derived unit, this is derived unit. Derived unit means what? It is using fundamental units. What is fundamental unit of length? Meter. Meter into meter, meter square. Density, kg per meter cube. What is velocity? Velocity, length by time. So meter by second or meter second inverse. Using length and time. And finally, force sampling. Finally, force, mass into acceleration. Force, mass into acceleration, you can write like this: kg into meter by second square, or some other name is given Newton now. Newton is SI special name. Like these are, Newton is SI fundamental unit. These are the derived units. What is derived units? It can be derived with the help of fundamental quantities. They are dependent quantities. Derived quantities are dependent quantities. Fundamental quantities are independent quantities. This is very, very important question. Next question. Next important question is, why do we have different units for same physical quantity? Why do we have different units? Different units for same physical quantity. For same physical quantity. For same physical quantity, why do you have different units? Answer. You take physical quantity length, for example. Physical quantity, you take length. Length can be measured, wide range of units are there. Length can be measured. Length can be measured in A bit meter, B bit centimeter, sometimes in millimeter, micrometers also, nanometers also you can use. So all units are for length only. Large lengths you are using. For the smallest length you want to use. So micrometer, micro, mm means millimeter, mm means millimeter, nm means nanometer. So different ranges, in different ranges of units, different will be there. So that's why we have different units for same physical quantity. For same physical quantity, a wide range of temperature, wide range of units are there. Similarly, if you take mass, mass can be measured. Mass can be measured in A, kilogram, B, gram. It can be measured in gram, kilogram, etc., milligram, etc., like this. So wide range of temperature. Mg means milligram, gram, mg, milligram. We'll write full form, milligram. So these are smaller units, this is bigger unit. 1 kg is how many grams? If you want to know, 1 kg is 1000 grams. Like that, length and mass will have different wide range of units of there. That depends on what you are measuring. You are measuring thickness. It will be in millimeter. You are measuring length of cylinder, it will be in centimeters or meters. So same length only you are measuring. Thickness is also kind of difference in length only, measurement only. So you can use meters or millimeters depending upon the reading. Right. That is the meaning of this. I think this is a typical question. Once again, I'm telling, why do you have different units for same physical quantity? What is the meaning of that one? Same length only can be measured. In meters, centimeters, millimeters. That depends on the measurement. I told just now, thickness by screw gauge, millimeters we are measuring. Length of cylinder, measuring in centimeters. Like that. Sometimes distance traveled by light in air. Light years you can measure. That is very large distance, astronomical distance. Distance traveled by light in 1 year. That is 9.46 in 10^15 meters. You can't measure its scale. That by parallax method you will do. Like that. Mass also. Kilograms, 1 atomic mass unit is there. Very smallest unit. Next question is that one only. 1.66 into 10⁻⁻27 kS. Like that, wide range of same quantity, wide range of units will be there. Different scales like that. Now, next question is express unified atomic mass unit in kgs. Express unified atomic mass unit. Express unified atomic mass unit in kgs. Answer. But so unified atomic mass unit. Atomic mass unit, I'm writing AMU atomic mass unit R1U is 1/12th of the mass of the carbon atom. Mass of the carbon atom. What is the value of this one atomic mass unit? Is nothing but equal mass of the proton 1.66 into 10 to the power of one atomic mass unit. One atomic mass unit or 1U. This is also called 1U. 1.66 into 10 to the power of -27 kg. This is called mass of the proton. So this is called unified atomic mass unit. This is the question. One more last question is there in units and measurements. What is that question? That problem they are asking in the examination. The percentage errors, sometimes they are asking, generally they are asking theory only units and dimensions, 99%. One question I'm doing is given in the previous examination. Telangana also 20. The percentage errors in mass and speed, the percentage errors in mass and speed, mass and speed, in percentage errors in mass and speed are 2%, 3% respectively, are 2% and 3% respectively. What is the maximum error in kinetic energy? What is the maximum error? What is the maximum error in measuring kinetic energy? Measuring kinetic energy. Kinetic energy. Measurement of kinetic energy. Kinetic energy formula we know. This is very, very important question. Answer. Kinetic energy, KE means kinetic energy, K is equal to half mv square. M is mass, V is velocity. M is mass, V is velocity. So kinetic energy is proportional to mv square. Half is constant. When your percentage errors is valid within 5%, delta K by K, if you write, nil to error, delta K by K is nothing but equal to delta M by M. What is M power 1? 1 into delta M by M. What is V power 2? 2 delta V by V. This is the formula. Delta K by K is equal to formula you have to write. Delta K by K is equal to delta M by M plus 2 delta by V. Percentage delta K by K, if you take percentage directly given, mass percentage is given 2%. Mass percentage 2% is given. This is 2% plus 2 into, this is given 3%. So 2% plus 6%. Answer is 8%. Answer is 8%. This is very, very important question. Delta M by M plus 2 delta V by V. So answer is this. So this is the end of the second chapter, units and dimensions and errors analysis, second question. Next chapter, we are going to take next chapter, motion in a plane. There is no very short questions in motion in a straight line. We are going to motion in a plane. So vectors knowledge will be necessary. In the scalars and vectors we are learning. Scalar is the physical quantity having only magnitude. Examples are distance, length, time, speed, work, power, energy. Vectors, physical quantities having both magnitude and direction and follow the laws of vector addition. Displacement, velocity, acceleration, force, etc. are weight, acceleration due to gravity, all are vectors. Again, vectors are what? Displacement, velocity, acceleration due to gravity, force, weight, etc. Secondary, you will get electric field strength, magnetic field strength also. So now I am telling motion a plane. Motion a plane questions we are discussing. Very important chapter. Motion a plane it is. Motion a plane. What are the questions we are studying? There are 5, 6, 7 important questions are there. Vertical component of vector. First question. Vertical component of a vector. Vertical component of a vector is equal to horizontal component of vector or x component. Horizontal component of the vector. Vertical component of vector is equal to horizontal component of the vector. What is the angle made by the vector with x-axis? What is the angle made by the vector with x-axis? So answer. What is the horizontal component of vector? You take vector a bar, x component ax I cap plus ay j cap. What is x component? Ax equal x component. It is called a cos theta. This is called horizontal component. This is called horizontal component. This is called horizontal. This is called vertical. Horizontal component. Horizontal component, vertical component. Ay is nothing but a sin theta. Okay, these are two are equal. It's telling horizontal component is equal to vertical component. Horizontal component is vertical component. That means a cos theta is nothing but equal to a sin theta. So a gets cancelled here. Sin theta by cos theta is equal to 1. Tan theta is equal to 1. Tan theta is equal to 1. Theta is 45 degrees. So angle made by the vector with x-axis. Angle made by the vector with x-axis. This is called horizontal component. This is called vertical component. Diagram is not necessary. Theta 45 degrees. Angle made by the vector with x-axis is how much? 45 degrees. So whenever the components are equal, angle made by the vector with x-axis 45 degrees. Okay, students, I think it is clear. Next question. Next question is, two forces of magnitudes 3 units and 5 units act at 60 degrees with each other. What is the magnitude of the resultant? Two forces of magnitudes. Two forces of magnitudes 3 units and 5 units. 3 units and 5 units act at 60 degrees to each other. 60 degrees to each other. What is the magnitude of resultant? What is the magnitude of resultant? Magnitude of resultant. What is the magnitude of resultant? Resultant means addition of vectors. Parallelogram solution. Resultant is given by the formula parallelogram law under root of a square plus b square plus 2ab cos theta. What is a value here? 3 units. What is the b value? 5. Theta is how much? 60. So formula carries 1 mark. Calculation carries 1 mark. 3 square plus 5 square plus 2 into 3 into 5 into cos 60. So this is 9. This is 25 plus 5 into 15 into 30. 30 cos 60. Cos 60 means half. So you are going to get 9 plus 25 plus 15. This will become root 49. 25 plus 15. So it is appearing at 25. 5 square 25. I think you can understand 5 square is 25 here. I'll write once again. 9 plus 25 plus 15. So 40 root 49. Answer is 7. Answer is 7. This is very, very important question based on parallelogram law. Parallelogram law. Next question. Next question. What is the angle made by the vector? A bar is nothing but I cap plus j cap. What is the angle made by this vector with x-axis? With x-axis. We will use a formula here, direction of vector. Tan of theta, coefficient of j by coefficient of I. Coefficient of j by coefficient of I, tan theta, with x-axis means. What is coefficient of j? Coefficient of j here 1. Coefficient of I is also 1 because I cap plus j cap. It implies that tan theta is equal to 1. Tan theta 1 means what? Mathematics says that theta is nothing but 45 degrees. Again, answer is 45 degrees. This is physics, we will use this method only. Somebody will use dot product method also. Dot product also you can use cos theta a bar dot b bar, or you can do alternative also. Some students will do, but this is the better method. Cos theta is a bar dot b bar by mod a mod b. That also they will use dot product. Here what will happen? A bar dot b bar. A bar dot b bar. I cap j bar dot with x-axis I bar. Magnitude of I cap. This is nothing but root 2 is 1. Cos theta is nothing but equal to I bar dot I bar 1 by root 2. Then also theta will become 45 degrees. This is mathematical method, but that is the better method physics. Directional vector tan theta. So this is the better method. Better method. Now I am taking another important question. P bar is nothing but, I am writing P bar is nothing but 2i plus 4j, 2i plus 4j plus 14k, P bar. Q bar is nothing but 4i plus 4j plus 10k. What is P bar plus, find the magnitude of P bar plus Q bar. Find the magnitude of P bar plus Q bar is modulus value. First you add, don't find out magnitude P. What is P bar plus Q bar? First you find out. 2i plus 4i, 6i, 4 plus 4, 8j, 14 plus 24k. P bar plus Q bar, 2i plus 4i, 4j plus 4j, 14 plus 24k. What is the magnitude of P bar plus Q bar? Under root of 6 square plus 8 square plus 24 square. This is 36 plus 64. 24 square is nothing but 576. 64 plus 30 is 100. Root 676. You can leave here, or you can find out square root of 676. That will be equal to 26 units. Root of 674. Root of 676 is 26 units. So this is a very, very important problem. Number of times asked in the examination. Then next important question is, what is the acceleration of the projectile at the top of the trajectory? This is very, very important question. Very simple question. You will confuse what is the acceleration of the projectile. What is the acceleration of the projectile? What is the acceleration of the projectile at top of its trajectory? At top of its trajectory. So answer, if you want to write answer, acceleration is always question. What is the, again I am writing students, what is the acceleration of the projectile? Acceleration of the projectile. What is the acceleration of the projectile? Anywhere at the top of the trajectory. At the top of its trajectory. Trajectory means path. Trajectory. Right, friends? Answer. On projectile is under influence of gravity. At the top of the trajectory, acceleration of the projectile is equal to acceleration due to gravity, is equal to acceleration due to A by equal to minus G. That is acceleration due to gravity. Anywhere, if you draw diagram also, anywhere is the trajectory projectile is asking at the top. This is the top. Anywhere acceleration due to gravity will be acting downwards. This is the acceleration. He is not talking about velocity. He is talking about the everywhere, not only here, starting point, everywhere it is G only. Everywhere it is G only. At the top of the also projectile will be under influence of gravity only, acceleration due to gravity, that is Ay is equal to minus G. This is very, very important question. So these are the questions, main questions in the motion plane. Motion plane. Next, we are going to next chapter. Next chapter, students, laws of motion. Laws of motion also very, very important. One very short question will come. Laws of motion. Laws of motion. First question, what is inertia? Laws of motion. We are having very short question. What is inertia? First, what is inertia? What is inertia? What is inertia? What gives the measure of inertia? What gives measure of inertia? Answer. Students, you know inertia. Inertia is natural property of the body. What is inertia? Inertia is a natural property of the body. Natural property of the body to remain in state. To remain in its state. State means state of rest or state of uniform motion. Inertia is the natural property of the body to remain in its state. Remain state means what? State of rest unless disturbed by extra or state of uniform motion. State of uniform motion. Uniform motion means uniform velocity. There is no acceleration. State of uniform motion. Mass is the measure of inertia. How to measure inertia? How to measure inertia? Mass is the measure of inertia. Mass is the measure of inertia. More the mass, more the inertia. More the mass. If the car is there, lorry is there. You know, practically lorry is having more mass. Lorry is having more inertia than car. Like that. This is very important question. Next question. When bullet is fired from gun, when bullet is fired from gun, gun kicks back in backward direction. Gun kicks back in backward direction. Backward direction. Explain. Explain. Is the question. The question: when bullet is fired from gun kicks back in backward direction. Why? Answer. According to law of conservation of momentum. This is according to law of conservation of momentum. Law of conservation of momentum. According to conservation of momentum, what will happen? Before firing, total momentum of the system is 0. After firing, m is the mass of the bullet, u is the velocity of the bullet, capital M is mass of the gun, v is velocity of the gun. You are writing the words: mass is mass of the bullet, m is mass of the bullet, u is velocity of the bullet, capital M is mass of the gun, v is velocity of the gun. It implies that mv is nothing but minus mu. What is velocity? Minus mu by m. Minus sign says that what is v? What is v? Velocity of the gun. That means that bullet goes forward. It implies the conservation of momentum. Bullet goes forward. Bullet goes forward. Bullet goes going forward. Then gun recoils. Gun moves backward, but not very fast. The gun is very heavy. It moves very slowly. Gun moves backward. That is the reason gun moves backward. Bullet moves forward, then gun moves backward due to conservation of momentum and because of this equation. If you want to write, you can write equation. Otherwise, you can write theory. So according to law of conservation of momentum, bullet goes forward means gun should move backward. Gun should move backward. This is. If a bomb at rest, next. Right. Next question. If a bomb at rest, explodes into two pieces. They must travel in opposite direction. They must travel in opposite direction. Explain. So here, bomb at rest explodes into two pieces. They must travel in opposite direction. Explain how they should move opposite direction. Answer. According to conservation of momentum. Again, using law of conservation of momentum. Law of conservation of momentum. Bomb is at rest initially. Bomb is at rest initially. 0 momentum is there. After they move two pieces. M1 is the one piece mass, velocity of one piece. Second piece mass is M2, velocity is V2. Law of conservation momentum, bomb at rest, two pieces. M1 is the mass of first piece, M2 is second mass of second piece. From this you can say M1 V1 is equal to minus M2 V2. This implies that M1 V1 is nothing but equal to minus M2 V2. That means minus sign says that. Negative sign says that. Pieces are moving in opposite directions. Pieces are moving, V1, V2 are opposite. Pieces are moving in opposite directions. Pieces are moving in opposite direction. Why they are moving in opposite direction? Because conservation of momentum, M1 V1 should be equal to minus M2 V2. Momentum of both the pieces are equal and opposite. Negative sign says that pieces are moving in opposite direction. This is the question. Very important one. What happens to coefficient of friction? What happens to coefficient of friction? What happens to coefficient of friction? Coefficient of friction if weight is doubled. If weight is doubled, this is very important question, number of times. What happens to coefficient of friction if weight is doubled? Answer. Coefficient of friction doesn't depend on weight actually. What is coefficient of friction? Coefficient of friction mu frictional force by normal reaction. Coefficient of friction, but mu doesn't depend on weight. Mu doesn't depend on weight. What happens to coefficient of friction? Weight doubled. Doesn't depend. So mu remains same. Coefficient of friction remains same. So mu remains constant. So mu remains the constant. Mu remains constant because coefficient of friction force by normal reaction doesn't depend on weight. So mu remains constant. So mu remains constant. This is the answer for this. But one more problem is there coming in the examination. What is that? I'm telling last question in this. Remaining are all theoretical. If you want, read one or two. You can read flattened tires, inflattened tires, and all that. But generally, they're asking these questions repeatedly for the past 3-4 years. Now, next question is, what is next question? Problem. A batsman hits back a ball straight in a direction of the bowler. Bowler without changing the initial speed. Without changing initial speed 12 meter per second. If the mass of the ball is 0.15 kg, determine the impulse imparted to the ball. Impulse imparted to the ball. Impulse imparted to the ball. So answer. What is impulse? Impulse, there are two formulae are there. Force into time, one formula is there. But one more formula, change in momentum is there. Is also equal to force into time is also equal to change in momentum. This is the formula. Impulse is nothing but change in momentum. So force is not given, time is not given. You use change in momentum because mass of the ball is given. What is happening? Ball is coming like this onto the bat and again hitting back like this, going back. So 12 meter per second, again returning back 12 meter per second. This ball hitting and coming back. This is ball hitting and coming back. What is impulse? Mass into impulse by the ball, exerted by the ball, m initial velocity, u, and coming back, minus u. So it will become 2mu. It will not become 0, u minus u plus u, 2 into 0.15. Velocity is nothing but 12. 2 into 0.15, 0.3 into 12. Nothing but equal to 3.6. Answer is nothing but 3.6 Newton second. What is the unit of Newton second you can write, or 3.6 kg meter per second also you can write. 3.6 kg meter by second, or is a force in time Newton into second. So impulse is equal to change in momentum, m into u minus u. U minus u plus u plus u, 2mu. m into 2u, 2mu, 2 into mass 0.15 into 12, 2 into 0.15, 0.3 into 12, 3.6 Newton second. This is very, very important problem they are asking in the examination. Sometimes very short questions, out of 10, 1 or 2 you are getting problems. This is regarding Newton's laws of motion. Next chapter is rotatory motion, system of particles and rotatory motion. System of particles and rotatory motion. Next chapter is system of particles. System of particles and rotatory motion. And rotatory motion. System of particles and rotatory motion. Rotational motion. One second. Okay. There are two very short questions is coming saying. Okay, let us discuss. Is it necessary? First question. Is it necessary to have a mass at center of mass? To have a mass at center of mass. At center of mass. Explain. Is it necessary to have a mass at center of mass? Answer. No. There is no necessity of mass. There is no necessity to have mass at location of center of mass. At location of center of mass. Is it necessary to have mass at center of mass? Explain. So answer is no. Example, ring, hollow ring. Conicoid, hollow ring. Hollow ring. Ring construct like this. Ring. Hollow ring is outside. This is called center of mass. It's outside. That is a very important question. So this is one very short question. Next, two rigid bodies. Next question. Two rigid bodies have same moment of inertia. Same moment of inertia. Two rigid bodies have same moment of inertia about their axis of symmetry. Same moment of inertia. Of the two, which will have greater energy? Out of the two, which will have greater kinetic energy? Which will have greater kinetic energy? Two bodies have same moment of inertia. Out of two, answer. What is kinetic energy? Formula. Kinetic energy of rotation formula is half I omega squared. What is I? Moment of inertia. I is called moment of inertia. Moment of inertia. Omega is called angular velocity. So both the bodies are having same moment of inertia. Therefore, kinetic energy is proportional to omega squared because I is constant. Therefore, greater the angular velocity. Greater the kinetic energy. Greater the angular velocity, greater the kinetic energy. That's directly proportional to omega squared. So if I is same, this is the formula. Kinetic energy is proportional to omega squared. Kinetic energy is proportional to omega squared. Greater the angular velocity, greater the kinetic energy. Omega. This is the answer. Next question, very important question. We cannot open or close the door. Applying force at hinges. We cannot open or close the door. We cannot open or close the door by applying force at hinges. By applying force at hinges. Why? So what is rotation means what? Open or close means rotation. Answer. You know, torque is used for this. Torque is nothing but force into level arm, perpendicular distance. Hinge, if you are applying hinge, there is a door, this is a hinge, this is the door. This is the door, this is the hinge, this is the hinge. You apply force in the hinge. You apply the force on the hinge here. Perpendicular distance is 0. There is no perpendicular distance. Applying force at hinge, this is hinge. Applying force at hinge. Perpendicular distance, a level arm, they will say. Force arm. Perpendicular distance or level arm is 0. Perpendicular distance is 0. Therefore, perpendicular distance is 0. Therefore, torque is 0. Therefore, no rotation effect. Torque 0. Torque is not there. The perpendicular distance is there. No rotation. You can't open or close the door by applying force at hinges. This is one question. Depends on torque here. Next, why do we prefer a spanner of long arm compared to the short arm? This is not 1 minute. So same formula. Why do you prefer a spanner of long arm as compared to spanner of short arm? Torque is equal to force into distance. So if you use spanner of long arm, perpendicular distance is more, torque will be more. Okay, students. Actually, nowadays, I think system of particles, they are giving mainly on short questions only. They have changed a little bit. They are not asking much on very short questions now. That's why 2-3 questions only we discussed here. So when we see the previous papers, we are not finding any question except in 22, fifth question is coming. That means one very short question is coming in this. So one more question I am discussing in rotatory motion. By spinning eggs on the tabletop, how will you distinguish hard-boiled egg from a raw egg? By spinning eggs on the tabletop. Eggs on tabletop. How do you distinguish hard-boiled egg from raw egg? Hard-boiled egg to raw egg. So answer. Boiled egg means what? What is meant by boiled egg? So in the substance will be like this. This is boiled egg. Boiled egg inside liquid will become solid like this. Boiled egg. Raw egg, liquid will be there. Particles are far away. This is raw egg. A boiled egg is nearly rigid body and has low moment of inertia. ఎప్పుడు ఇంకా కాలే కదా క్లాస్ ఇంకా ఉంది కదా నాకు దానికి ఆన్సర్ చేయమంటాడా ఏంటి క్వశ్చన్ ఏంటి కానీ ఇది ఓన్లీ వెరీ షార్ట్ క్వశ్చన్ ఇంకా అవ్వలేదు 3 రోజులు పడుతుంది అబ్బాయికి చెప్పండి నేను చెప్పనా చెప్తా My dear students, don't worry, Nana. Today we are going to explain only very short questions, Nana. So I will give you at the end of the third day, Saturday, overall important questions I will give you. I think you can catch me. I am telling only Very short questions, madam. Whatever very short questions I am telling you, please follow this one. This is your 10 into 20 marks. But I understand your botheration. Generally, students will prepare first long questions, then short questions, then very short questions. Very short questions lastly they will read. That's why, because the first time doing very short questions, you are not in favor of that. But tomorrow I am discussing short questions, 4 marks questions. So I am mainly discussing most important questions only. I am discussing most important questions. Today I cannot make out important questions. Tomorrow again 3 to 5 one class is there, short questions. Saturday also 3 to 5 long questions is there. Last half an hour of Saturday, after finishing that, I'll tell overall important questions, long questions, short questions, a list I'll write on the board. You can note down. Is it clear? So boiled egg, by spinning eggs on the tabletop, how will you distinguish hard boiled egg from a raw egg? A boiled egg, you are seeing boiled egg like this, raw egg. Same torque. Boiled egg spins faster. Boiled egg spins faster. Boiled egg spins faster. Raw egg, liquid matter would tend to move away from the rotational axis. This would increase the moment of inertia. So when you take here boiled egg and you write I1 omega 1 and 1 for 1 angular momentum, another thing is N2 I2 omega 2. Moment of inertia will be more. So moment of inertia I2 is greater than I1, moment of inertia. For raw egg it is more. So I2 is greater than I1, omega 2 is less than omega 1. Omega 2 is less than omega 1. A boiled egg is nearly rigid body, hence the same torque is applied, spins faster. It spins faster. What is spins faster? Spins faster. Boiled egg, so same torque, some same torque. So torque is nothing but, of course, torque you will take I alpha, omega 2 minus same, but right like that, and see that. So which will spin faster? Boiled egg spins faster because having lower moment of inertia. Because lower moment of inertia, angular velocity will be more. Angular velocity will be more. Next, I am going to the next chapter, students. Next chapter is, we don't have all these gravitation and all these things. Mechanical properties of fluids, friends. I am discussing now mechanical properties of fluids. Mechanical properties of fluids. I am discussing today very short questions of the chapters only. Mechanical properties of fluids. Fluid means liquid or gas. There are very, very important questions. Mechanical properties of fluids. I am discussing one by one mechanical properties of fluids. Mechanical properties of fluids. One is define average pressure. Define average pressure. Define average pressure. Define average pressure. Mention its units in dimension formula. Mention its unit and dimensional formula. Dimensional formula. Is it a scalar or vector? Is it scalar or vector? Okay, answer. The average pressure. Pressure average. Normal force by area of cross section. Area of cross, that means force by area, average force by area. This is the formula for average pressure. What is the unit? SI unit. SI unit is Newton per meter square or Pascal. SI unit is Newton per meter square or Pascal. Dimensional formula. DF means dimensional formula. DF means dimensional formula. ML minus 1, T minus 2. How to get force by area? Force dimensional formula, ML T minus 2 by area L square. Is scalar. Is it a spectra scalar? It is a scalar. It is a scalar. Okay.
Sir, can we collect questions enough
I'll answer. My dear, I think 50 plus to get 55 can't guarantee, but 50 plus to get probably I'm thinking baby bullet is enough. For example, you are feeling very hard, you can read baby bullet. Definitely you can feel baby bullet. I've seen baby bullet book also. It is quite satisfactory only. Your luck is there, you will get above 55 also, even 57 also. But 60 out of 60, above 55 depends on how you represent. How do you represent your answers, even though you are reading baby bullet? But baby bullet thoroughly you are reading and answering. Definitely, if you get above 50, you get above 50. I can give guarantee, right? Legibly 52, 53, or 54 also you get. But 60 out of 60 getting presentation. Certain questions he has not given full matter. Certain questions. What I observed is that certain questions he has not given complete answer according to textbook, because textbook is our basis. So many materials are there, so many market. But nowadays, most of the students in the market are using baby bullet only. This year I have seen. So I think definitely without worry you can study. Either very short questions or long questions or short questions, baby bullet. That is better. Instead of getting mark better. Definitely you can confidently you can read. Your luck is there, you can get above 55 depending upon your presentation. Okay, student? Right. I will all answer. You can bring your baby bullet also to your classes, and we can see tomorrow. Tomorrow crucial. Short questions I'm discussing 3 to 5. Day after tomorrow I'm discussing long questions. Crucial. Long questions. 5 questions we discuss. You can answer 3. You can answer 2 out of 3 to answer you. But very short questions only crucial. But next I'm telling you. Maths, I don't know, student. I am physics lecturer, Srinivasan. I know about physics. Some other sir will tell you. Some other sir also will present this IP presentation for you in YouTube classes. So some other time will be there for that. In that time, definitely he will tell you how to approach towards mathematics A and B. Chemistry, physics is not the same only, almost. But chemistry weightage topics also chemistry sir will tell. Now I am telling physics. Today, tomorrow, and day after tomorrow, physics. So, right. Now I am continuing my lesson. Pressure is scalar, student. Pressure is scalar. Next question. Define viscosity. First, today's lesson, my dear students, I advise all of you, those who are keeping messages, I'm happy. But today's class, you concentrate, you will be benefited. Either any book you are following, you will be benefited. Today's lecture, you solve you very short questions, including problems today nicely to you. After end of today's class, again tomorrow's class, you observe short questions, you will get clarity. Like that. Day after tomorrow, full clarity you will get. Day after tomorrow, by evening, you can answer me. You can ask plenty of questions for 15-20 minutes at a time. That. Define viscosity. What is its units and dimensions? What are its units and dimensions? Viscosity is nothing but friction between the layers. Viscosity is nothing but friction between the layers of fluid. Friction between the layers of fluid or liquid. Layers of liquid. It opposes the relative motion. It opposes viscosity property. It opposes the relative motion. It opposes the electric friction. It opposes the relative motion. Relative motion between the layers. What is the coefficient of viscosity? SI unit. SI unit is Pascal second. SI unit is Pascal seconds or poise value. CGS unit also I am writing. Poise. CGS unit is poise. Dimension formula. What is dimension formula for viscosity? Coefficient of viscosity. Dimension formula of coefficient of viscosity. That dimension formula you can derive, but you can remember for time being mn minus 1 T minus 1. Dimension formula for coefficient of viscosity. But this is not asked many times, student. You can forget about this question. Next question. What is the principle behind carburetor? What is the principle? You know carburetor in Indian. What is the principle behind carburetor? Principle behind carburetor. Carburetor. Of an automobile. Carburetor of an automobile. What is the answer? This is very, very important question. What is the principle behind carburetor? Carburetor works on Bernoulli's principle. Carburetor works on Bernoulli's principle. Carburetor works on Bernoulli's principle. Bernoulli's principle. Working on Bernoulli's principle. So there is a Venturi. What is the method here? It consists of Venturi channel. It consists of a nozzle. Venturi channel consists of a nozzle through which air flows. Through which it consists of a nozzle through which air flows. Through which air flows with largest speed. Nozzle. Air flows with large speed. Air flows with large speed. Pressure is lowered. So I can't balance when pressure is lowered. So pressure is lowered. Speed is more. Pressure is lowered. At the neck. At the narrow neck. Pressure is lowered at the neck. And petrol is sucked to the chamber. Petrol is sucked to the chamber. And it will burn. Chamber to provide correct mixture of air to fuel. It provides correct mixture of air to fuel. Then fuel will burn and you will burn. But here mainly you are right. Carburetor works on main point is what? Bernoulli's principle. This is the first point. Air flows with largest speed. Second point. Pressure is lower. Third point. This is enough. Pressure is lower. These 3 points you write. Carburetor works on principle of Bernoulli's principle. The concept of nozzle through which air flows with the largest speed. Pressure is lowered. So then, why drops and bubbles are spherical in shape? Why drops and bubbles are spherical in shape. What is the reason for this? It's a very important question. We are asking. Answer: due to surface tension. Answer you are right. You get 1 mark. Due to surface tension. Spherical. For a given volume, I assuming spherical due to surface tension. For a given volume, sphere has minimum surface area. That's why they are spherical. Why they are spherical? Bubbles and drops and bubbles are spherical in shape due to surface tension. One reason. That is the main reason. 1 mark. For a given volume, sphere has minimum surface. Why not assuming cubic? Where spherical means for a given volume, sphere has minimum surface area. Now, next questions are very, very simple and important. Give the expression for excess pressure. In this 2 very short questions will come, my dear students. Mechanical properties of fluids, 2 very short questions will come. 2 into 2, 4 marks. Give the expression for excess pressure in drop, excess pressure in a liquid drop, What is the answer? Answer is excess pressure P is given by 2T by R. Excess pressure drop. T is surface tension. R is the radius of the drop. What is the formula? Excess pressure liquid drop is 2T by R. T is surface tension. R is the radius of the drop. Next, give the expression for excess pressure in air bubble inside the liquid. Give the expression. This is very confusing. Please study very carefully. Drop means 2T by R. Give the expression for excess pressure. Pressure in an air bubble. Inside the liquid. Air bubble surrounded by liquid. Inside the liquid. Excess. Give the expression. Give the expression for an air bubble. In an air bubble inside the liquid. Answer is again 2T by R only. Bubble inside the liquid. Bubble formed inside the liquid. Only one free surface you can take. Bubble inside the liquid. Only one free surface. Therefore, again T surface tension you write. C surface tension, T is surface tension, R is radius. This is the answer. Excess pressure of the air bubble inside the liquid. In this last question is give the expression for excess pressure inside soap bubble. Give the expression for excess pressure in the soap bubble in air. Soap bubble in air. Answer. Soap bubble in air, surrounded by air. Excess pressure is 4T by R. Two free surfaces will take. This is the formula. Formula changes. Two places you are getting 2T by R, now 4T by R. T again surface tension. P is called excess pressure. Surface tension. P is called surface tension. R is called radius of the bubble. Radius of the bubble. So these are the questions mainly in mechanical properties of fluids. What is angle of contact? That is given only once. You read the definition. Angle between the solid body inside the liquid and angle between when body is dipped in liquid, angle between solid surface and tangent drawn to the liquid surface is called angle of contact. What is angle of contact? Sir, pages కావాలి సార్ నితిన్ సార్ పేజీ కావాలి. అయిపోయింది. ఇంకో 2 చాప్టర్స్ ఉన్నాయి. అయిపోయింది. ఇంకో 2 పేజీలు కావాలి. పేజీలో పేజ్ రావట్లేదు. పేజ్ ఒక నిమిషం 2 minutes యాడ్ చేయండి. ఇంకా 2 చాప్టర్స్ ఉన్నాయి. థర్మల్ ప్రాపర్టీస్ ఒకటి, యాంటీ ప్లస్. Just 2 marks. What is angle of contact? This is given only once, Nana. So if necessary, last class I'll discuss what is angle of contact. I'm giving you what is angle of contact. Angle of contact. Angle of contact. Angle of contact definition. What is angle of contact? What is angle of contact? What is angle of contact? Angle between when it is dipped, solid body dipped in liquid. When solid is dipped in liquid, The angle between tangent drawn at the angle between the tangent drawn at the solid surface and liquid surface. At solid surface inside the liquid, solid surface inside the liquid and liquid surface, solid surface and liquid surface. So angle of contact, water and glass. Example, answer. To take water and glass, solid water and glass, angle of contact theta, theta less than 90 degrees. Mercury and glass, pure glass, theta is greater than 90. If the approximate theta is 140 degrees, you will get mercury and glass. Here theta approximate theta is equal to 0 degrees, you get pure water and pure glass. So this is very rarely they are asking angle of contact. So now we are going to next chapter, like thermal properties. We are going to thermal properties now. Thermal properties. We are having thermal properties. These are two easy chapters are there. One is kinetic theory of gases, another is thermal properties. Thermal properties, students, in heat. Thermal properties. First question. Distinguish heat and temperature. Distinguish heat and temperature. Distinguish heat and temperature. This is very general answer, I am telling. Heat is a form of energy. You can write tableau form also. Heat is a form of energy measured by calorimeter. I am writing separately. Measured by calorimeter. SI unit is joule. Heat energy SI unit is joule. That is J. CGS thermal units. Calorie, CL cal. Temperature, what is temperature? Temperature tells about direction of flow of heat actually. Temperature is degree of hotness of the body. Measure of heat. Temperature is nothing but measure of heat. Degree of hotness of the body. Degree of hotness or coldness of body. Measured by thermometer. It is measured by thermometer. Liquid thermometer mainly you take. Units are SI unit is Kelvin, K. CGS unit is degree centigrade. So this is the distinct heat. Heat is a form of energy. SI unit is joule. CGS unit is calorie. Measured by calorimeter. Temperature, degree of hotness of coldness of body. Degree of hotness or coldness of body measured by thermometer. This is a very, very important question they are asking. Next important question is, why gaps are left between two rails? That is also not given TS but AP. A small gap is left between the rails to allow for expansion in summer. Why do liquids have no linear and aerial expansions? Why liquids do not have no linear and aerial expansions? Only volume expansion is there. No linear and volume expansion. This question. Answer. Liquids assume the shape of container. The shape of container. Shape of container means cubical. Shape of container. Hence it has only volume expansion. It has only volume expansion. Linear area are negligible. Linear means lengthwise. Aerial expansions are negligible. They are not accountable or negligible, because assume the shape of the container, volume expansion only will take. That is one important question, even TS19. Huh? Doubt, huh?
Sir, I have doubts. If I write the LAQs SAQs answers, which I learned from baby bullet, will they give full marks for the answer in the final exam? This is chemistry as well.
Okay. Students, I'm encouraging you, 90% you will get marks. Out of at least 8, you will get 7 marks. But generally, long question is linked with 6 marks. B bit problem will be there. Problem is not there. For example, mention the types of collisions. I'm telling about first year. What are types of collisions? And explain them. Derive the expression for final velocity of the collisions. B1, B2. But that problem is not there. You select such a question where problem is not there. So if you write baby bullet, that information, I'm not completely seen, my dear student, baby bullet, but generally as a teacher I see the textbooks. So Telugu Academy textbooks, but I have
Yes, sir. ఇక్కడ నుంచి ఉండదండి.
Okay, students, state Finn's displacement law. Wavelength for which energy is maximum inversely proportional temperature. Lambda and V is constant.
ఇదే లాస్ట్ ఇయర్.
Lambda is inversely proportional temperature. This constant is called, this V is called Wien's constant. V is called Wien's constant. Whose value is, Wien's constant value is 2.9 in 10 power minus 3 meter Kelvin. This is Wien's displacement. The last question.
లాస్ట్ ఛార్జింగ్ లేదు.
అది లేదు. మరి ఇంకోటి క్యాంటీన్ తిరిగి ఒకటి క్యాప్టెన్ వెళ్ళిపోయింది.
అది లేదు ఛార్జ్ లేదు. ఇప్పుడు మళ్ళీ స్క్రీన్ మధ్యలో ఆగిపోతే కష్టం.
ఓకే, నో ఇష్యూస్. సార్ చెప్పండి, ఇంకొక 10 నిమిషాలు పడుతుంది.
ఇప్పుడు ఛార్జ్ లేదు సార్.
అది కాదు, నేను బిల్ చెప్తాను. 10 నిమిషాలు పడుతుంది సార్. కాకుండా 10 నిమిషాలు అంటే ఇంకోషన్గా తీసుకుంటాను. ఇంకెప్పుడు లేదు. సైంటిఫిక్ ఎడ్యుకేషన్ అని చెప్తున్నా. అయిపోతే మీకు ఇవాళ ఏదో ఒక చోట అయిపోతుంది. ఫ్యూచర్ ఇక్కడ చూసుకోలేదు. కంటికి తిరిగే క్వశ్చన్ ఒకటి, 2, 3.
ఏడే స్విచ్ ఆఫ్ అయితే తెలియదు సార్. ఏడే స్విచ్ ఆఫ్ అయితే తెలియదు. ఛార్జ్ లేదు అలా.
Students, almost I completed very short questions except one chapter, kinetic theory of gases. That is very important. In that, 2 very short questions are coming. That will resume tomorrow at 3 o'clock. 3 o'clock, 10 to 12 minutes. It will take kinetic theory of gases, which is a part of chemistry also, that questions. So we'll do tomorrow. Thank you, students.